behave now. Yeah, I told Ryan I would put this video out during homeroom. Okay, so guys, let's get quiet. 6 and 7 have been asked about. Are there any more that we need to go over besides those two? Okay, let's go then to number 6. So, like we talked about that day, the connection that we made between vertical and horizontal, or I'm sorry, exponential and logarithmic equations was, thank you, when we have exponential equations, we had already talked about the two different ways to solve. One, we can either make the bases the same or they were already the same, so we could drop the bases and then solve the remaining equation. Or if we couldn't do that, we could rewrite it as a logarithm. Then we jumped into the logarithms. We said same thing. You got two options. If log equals log, like this problem, we can do what? We can drop those logs. And then we can take what's remaining and we can solve. The other one, of course, is if we don't have log on both sides, we can rewrite it as an exponent. So here's the way we wanted to process number 6, drop the logs. And now, of course, it's just solving a problem. So in this particular one, what I did is, because I'm dividing by x, I simplified this problem by getting rid of that. How did I get rid of that? I multiplied by x. In doing that, I moved it to the other side. It canceled on the left and left me with x minus 2 equals 5x. And then, of course, from here, it's pretty simple. We want to get our x's together, get our variables together. So, personally, I like to move the small one. That's the x. So I subtract that x. So negative 2 will equal, what's 5x minus 1x? 4x. And then lastly, to break that 4 away from x, we divide. And negative 2 divided by 4, you had two really good options. Negative 2 over 4 would reduce to negative 1/2. Or just as good as that, as a decimal, is negative 0.5. And that's 100% fine as well. So there's number 6. All right? Hopefully you see where you struggled possibly. If not, feel free to ask. Number 7 was the exact opposite type. Now, this did have one little catch. It had log base 8 of the argument, 28 minus 20. But then you also had that plus 15 on that same side. We're not ready to solve until your logarithm is alone. So I needed to move the what? I have to move that 15 first. I have to. So how do I move that 15? You subtract 15. So what is 18 minus 15? Now we're ready to go ahead and solve. Because I don't have log on both sides, I'm not dropping the logs. Can't do that. So here, instead, I'm rewriting it as a what? I'm rewriting it as an exponent. So the base of my log, 8, becomes the base of my exponent. And then we do the same loop that we've talked about all along. 8 to what power? The third power equals what? All right, exactly. 8 cubed is 512. And now we simply want to solve for k. So what's the first thing I need to do to solve for k? Not mine, it is negative. So I what? I add 20. So that's 532 equals 28k. And then lastly, and 532 divided by 28 equaled 19. So k equaled 19. So there it is, guys. That's how you solve. And thankfully 7 and 6 gave us both perspectives, whether log equals log, drop the logs, or log equals a number, rewrite as an exponent. We got to see both of them. So very good. All right. So there's no other questions? Feel good? So like I said, today we're going to move into graphing. And then tomorrow we're going to review for a quiz on Thursday. Okay, Friday we got a lesson over this thing called natural logs. What we've done so far is common logs. It's L-O-G. Friday we're going to jump into these things called natural logs, which is L-N. So we'll discuss that on Friday. The biggest concern right now is your quiz on Thursday. Okay, I want you guys to do good on that thing. So before we look at today's notes, before I hand them out, I want you guys to continue with the connection that we've been talking about. So please pay attention on your phones put away. I want y'all to focus. I feel a lot of you guys are really distracted today. So on Wednesday of last week, we really tried to make a connection between what type of functions? Exponential and logarithmic. Now, up to this point, which one of these have we actually graphed? Exponential. Yep, we've graphed these exponents. Remember, we called them, you either had exponential growth or you had exponential decay. And when we graphed these, I introduced something that was kind of new to us. It was this word that started with an A. Anybody remember it? Asymptote. An asymptote. Y'all remember? Your exponential function could not cross your asymptote. Do you remember what kind of asymptote it was?
What do you mean by type?
Yeah, there's two types of, well, there's actually more than two types. There are types of asymptotes, and this was one of the types. What type of asymptote did a exponential function have? It was horizontal. It was horizontal. It was a horizontal line that the graph just could not cross, right? A horizontal line that exponential function could not go below, right? We said in its simplest form, when there's no transformations whatsoever, your horizontal asymptote is defined as what? Y equals 0. Y equals 0. You with me? Now take this y equals 0. What did cause it to change? Your horizontal asymptote was affected, Kaylee, it was affected by, what is this? Vertical shift. Vertical shift affected horizontal asymptotes. Y'all remember that? Yes? Okay, now, please remember the connection that we've talked about. The reason I want to show you guys this before we move into it is because before just jumping in and graphing these things, it's helpful, in my opinion, to understand that exponential functions and logarithmic functions, they have that inverse connection, okay? And because they have that inverse connection, if a exponent has a horizontal asymptote, what do you think a logarithmic will have? It's going to have a vertical asymptote. There's going to be a vertical line that this will not cross. Do you understand? They're inverses to each other. Exponential has a horizontal asymptote. Logarithmic has a vertical asymptote. If it has not had a transformation, what do you think that vertical asymptote will be? What equals 0? X equals 0. Just like an exponential has y equals 0, defining the horizontal line, a logarithmic has a vertical asymptote that's defined as x equals 0. And the last thing, if a horizontal asymptote was affected by vertical shift, what do you think is going to affect a vertical asymptote? Horizontal shift. If you understand the connection between these two things, it's going to make the understanding of these graphs a lot easier. Because we already talked about exponential functions. Today we're talking about logarithmic functions. If I understand the connection between the two, you should understand that this is what happens. This is what occurs. Okay? It's still going to have the same general shape, It's just going to be turned differently, okay? So that's what we're talking about today. We should knock this out pretty fast. You shouldn't have really any problems with it. I hope that we keep the same momentum that we had last week, where we actually were able to understand the lesson so well, most of us were finishing the assignment before class was over. That should happen today, because this is not, rocket science. Oh man, I'm grabbing enough paper. I'm one short. Okay, so here we go. You definitely need your graphic calculator. But this is the connection that I hope that you guys will take with you into today's lesson. And it'll make it a lot easier. There's another connection that will continue. So let me explain a couple things real quickly before we jump to our graphing calculator. One, I want you to understand that not just because I told you guys these were inverses to each other, I want to prove it to you. Okay? So everybody pay attention, please. What do y'all know is another way of defining f of x? Y equals, right? So that's another way of writing that exponential function. Then I'm going to do something else before we actually solve it. I'm going to switch the sides. So instead of y equals 2 to the x, I'm going to change it to 2 to the x equals y. All right? Remind me, how did we come up with the inverse of a function? Y'all remember when we studied inverses the very first day of this 9 weeks? How did we say we found inverses? We switched x and y and solved for y. Here's the point. If I switch x and y here, that'll change this to 2 to the y equals x, correct? If this is an exponential equation, how do I solve for y? If this is an exponential equation, how do I solve for y? Well, do I have bases the same on both sides? So I can't drop my bases. Remind me, what's the other way of solving an exponent when I don't have bases on the same side or on opposite sides? Rewrite it as a logarithm. If I rewrite this as a logarithm to solve for y, the base of my exponent, 2, becomes the base of my log. And then we do the loop, right? Log base 2 of what? Equals what? Y. See how that's what you end up with over here? A exponential function and a logarithmic function are inverses to each other. I just proved it using that method that I showed you guys the very first day we came back after Christmas break. Right? So, you understand that there is absolutely a connection between exponential functions and logarithmic functions. Okay? Now, let me go remind you guys a couple of things about these exponential functions, and then watch what happens to the inverse, a logarithmic function. So let's go to our calculator. I'm going to reset mine real quick, because I did some things in it that I don't want it to remember. I zoomed in on my graph, and instead of zooming back out, sometimes it's easier just to reset it. If someone else did that to your calculator, it's easiest just to reset it. So we got 2 to the x. Now look, guys, did this shift up or down? Did it have vertical shift? So what should be the horizontal asymptote? Y equals 0. Let's see. If I graph it, sure enough, it never crosses the x-axis, just like we had talked about previously when we studied this. So if I look at the table, I'll come up with a couple of nice points, then we'll go back to our graph. So I've got, let's see, 0, 1 is nice. I've got 1, 2, 2, 4. And let's see if we can find one more. Yeah, there's 3, 8. You don't need all those points. But here we go. This is the graph we've already done, guys. Remember, I cannot cross y equals 0, right? So when I graph this thing, I'm going to hug that x-axis as I make my way up and through these points. Now, what was my horizontal asymptote? Y equals 0. It had no vertical shift. All right, now back to what we had learned about domain. Guys, what was the domain? Could it go left forever? Could it go right forever? So what did we say about our domain of exponential functions? Unlimited, right? Are y'all with me? What was limited though? My range. I can't go below my asymptote. I can't go below 0. Now, doesn't this graph go up forever? But I cannot go below 0. Y'all remember all that? Okay, so let's go to a logarithm and look at the differences. So let's clear this out. Do alpha window, number 5, log base 2 of x. Sorry. And now let's graph it. Notice the difference. What will this one not cross?
The y-axis.
It won't cross the y-axis. Why? Because it has a vertical what? Asymptote. And what was the equation for it? X equals 0, right? The opposite of what an exponential function have. Now, let's find a couple of nice points. Second graph. Looks like 1, 0 is nice. 2, 1 is nice. 4, 2 is nice. And let's see if we have one more. Let's see. Yeah, right there. 8, 3. Okay, let me go back to my paper. Because now I'm going to graph this thing where it never crosses the y-axis, but it goes up and through all of my points. Now look at the difference, guys. Instead of having a horizontal asymptote, y equals 0, it had a vertical asymptote at x equals 0. What happens to your domain of a logarithmic function? Can it go left forever? No, that vertical asymptote gets in the way. It can't go past what? Now I can go to the right forever, but it cannot go past that vertical asymptote. What about range? Can it go down forever?
Yes.
Can it go up forever? So the range is unlimited. So what do you notice? What's the connection between the exponential function and the logarithmic function? The domain and range are inverted, right? What was the domain for exponential is now the range for a logarithm. What was the range is now the domain. You think that's a coincidence? No, of course not, okay? That whole connection we've been talking about continues on, okay? Now, the last thing is this. If that shift happens inside the parenthesis, okay, pause. Go down to number 3 and 4 on the back. Go flip over real quick. I want you just, while they're right next to each other, I want you to notice the difference. Number 3, you have log base 4, and what's your argument here? Since there's parentheses, your argument is x minus 1. That's the part, it's all inside. But if you look at number 4, what is the argument of log base 3? Just x. So there's a difference between when there's parentheses and when there's not. When there's parentheses, that shift is happening inside, therefore it's what? What kind of shift happens inside? Horizontal. Is everybody with me? So on number 3, because there's parentheses, that shift is happening inside. It's horizontal. But on number 4, there is no parenthesis. So where's that minus 2 happening? Guys? It's happening outside, and therefore it's what, Gabby? It's vertical. So do you see the difference between those two? So let's go back up to our notes on the front side. If that shift happens inside the parentheses, then it is going to represent my new vertical asymptote. And because it's inside, it's the opposite, right? Y'all know that. If it's inside, it's the opposite. So plus actually shifts to the left, and therefore will give me what kind of number? Not all at once. Negative. If it's minus, it actually shifts to the right, and therefore gives me a, okay. Can y'all remember that? So let me do a couple of these graphs, and then I'm going to take you through those last four. It's going to take no time, I promise. But I want you to see this, okay? Before I graph this, where's this x plus 3 happening? It's happening inside, isn't it? So this thing should be shifting to the, it should be shifting to the left 3, and therefore changing my asymptote to be what? X equals negative 3, correct? How much you want to bet that's right? All right, let's go see. I'm going to go graph it. Y equals alpha, window, Braden, going to bust you up. Number 5, that's log base 2. And then inside the parenthesis, we're putting x plus 3. And I'm graphing it. All right, so see, did it shift left 3? Absolutely. So let's go find a couple of nice points. So I'm going to go up to where it is undefined. So there's a good one, negative 2, 0. That's a really good one. Because that's also a what? What do you call that? What do we call negative 2, 0? We got negative 1, 1. What do we call negative 2, 0? We got 1, 2. Surely somebody knows the answer to that. It's the x-intercept. Very good. We got 5, 3. So I've got enough good points. Let me go back to my paper, and then we'll answer all these questions really fast. Look, I cannot touch my what? I cannot touch my asymptote. So I'm going to just get real close to it, coming up and through all of these points. Boom. That's a beautiful looking graph. So what's my domain, y'all? Negative 3 to positive infinity. Perfect. Who said that? Oh, you said negative what?
I said negative 2.
Yeah, now negative 2 is the x-intercept, but remember, your graph can go a little further to the left. It just can't go past that vertical asymptote at negative 3. What about my range? Very good. Negative infinity, positive infinity. And last, your x-intercept is negative 2, 0. Y'all told me that just a second ago. All right, go to the bottom. Or the back side, sorry. We're going to go back to y equals. I'm going to clear this off. Alpha window number 5. I'm going to put 1 divided by 3 in the base. Now listen, here's the trick. I can't stop my calculator from putting parentheses, can I? When I push alpha window number 5, it just automatically puts it. Now here's where I have to fix this. In my graph, or in this problem that we're graphing right now, is x minus 1 in parentheses? No. So we have to tell our calculator that x minus 1 is not all together in the parentheses. So what is the only thing we put in the parentheses? You put the x in there. Then you scroll outside to say, hey, listen, that minus 1 is not a part of that. Okay, so that's what you have to do when the shift is outside. You put the x inside, but then you shift or scroll outside to put the minus 1. Now, that means since there's nothing inside the parenthesis, this thing is not shifting left or right, is it? So what should my asymptote be? It should be x equals 0. It should be right on the y-axis. So let's graph it and see. And sure enough, does this thing ever pass that y-axis? No. Now I know I kind of lose view of it. Remember, your calculator only has a certain amount of pixels, and it gets really close and just can't show that. But it cannot go past y equals or x equals 0. Can't go past the y-axis. Now let's find a couple of nice points and graph it, and then we'll be almost done. So we've got 1, -1. We've got 3, -2. Let me see if I can find one more nice point. Scroll down. There it is. 9, -3. That's pretty good. Those are 3. That's plenty. So my knowledge of this tells me I cannot pass my asymptote, but then I need to go through my points. What did my calculator not give me this time that it gave me last time? Well, let me get there. Domain, what is it? What can x equal? It cannot go past your asymptote at 0, but it can go to the right forever. What's my range? Unlimited, right? What did my graphing calculator not tell me in my table this time that it told me last time? My x-intercept. So there's 2 really good options. Okay, are y'all listening? There's 2 really good options. 1, I can go back to my graph and I can zoom in. And if I zoom in, I can now scroll and I can get really close to that intercept. Are y'all looking? I can zoom in again if I want to get really close. But look at this. As I get closer to it, that's pretty close to it, isn't it? And what does it tell me it is?
0.32.
0.32? If I went to the right, I may be a little past it now. What's that say? 0.37. So what do y'all think would be a pretty, really close estimate? 0.33? 0.34? Something like that? Let's just go with 0.34. So I can get a really close estimate just by zooming into my calculator. Now, there's one more way I'm going to show you, and then we'll be really close to done, okay? Because this is how easy this is. What do you know about x-intercepts? At any x-intercept that exists, what do you know is true every time you have an x-intercept? Think a little bit. At every point, at this x-intercept, at this x-intercept, at this x-intercept, at this x-intercept, at every x-intercept that could possibly exist, what do you know has to be true? Y equals 0. Correct? At every x-intercept, y equals 0. Guys, what does f of x stand for? Y. So how could I find my x-intercept if my graphing calculator doesn't tell it to me? I could set this equal to 0 and solve. Look, log base 1/3 of x minus 1 equals 0. What would I need to do? Because this minus 1 is not in parentheses, what would I need to do with that first? I would need to add 1. What's 0 plus 1? 1. How do I solve this? Is this log equals a log? No, it's log equals a number. How do I solve it? We rewrite it as a exponent. The base of my log, 1/3, becomes the base of my exponent, and then we do the loop. 1/3 to what power? The first power equals what? Guys, what's 1/3 to the first power? 1/3. Guys, what's the decimal value of 1/3? Did we get pretty close when we estimated it using our calculator? 0.34? We got really close. In fact, if you remember, Caden said 0.33 or 0.34. 0.33 is exactly. Okay? The point is this. If you don't have a graphing calculator, you can still find those x-intercepts. Just solve. Set it equal to 0 and solve. Now, These last four, watch how fast we can do this, okay? We can answer 3 of the 4 questions like this, okay? Watch, asymptote. Did this shift left or right? What did it do?
Move right 1.
So what did my asymptote move to? X equals 1. So therefore, my domain shifted to what? 1 to infinity. And what is the range always for logarithms?
Unlimited.
Unlimited. Negative infinity to positive infinity. We just solved those 3 questions in like 2 seconds. Look at number 4. Did it shift left or right? Did it shift left or right?
Yes.
You have parentheses? On number 4, are there any parentheses? There's no parentheses here around that x minus 2. So did it shift left or right? No. So what does my asymptote remain? X equals 0. So what's my domain? 0 to infinity. What's my range always? See how easy we answer those 3 questions? Look at number 5. Is there parentheses? So did this shift left or right? Which one? Left. So negative 9. So what's my domain? Negative 9 to infinity. You're exactly right. And then range is always unlimited. Look at 6. Does it have inside or parentheses? So which way did it shift? Right means positive 2. Domain then is 2 to infinity. Range is always. Okay, now we just answered 3 of the 4 questions for each of these so fast, right? You don't really have to think hard. You just have to look for parentheses or not. The last one, of course, takes a little bit more effort, and you've got 2 options. You can either graph it and look for the x-intercept, like we did a second ago, or you could set it equal to 0 and solve. I don't care which method you use. Graph it, find the x-intercept, or take your log, in this case base 4 of x minus 1 in parentheses, set it equal to 0 and solve. Is there anything I need to move here on that problem? Nope, so I rewrite it as so 4 to the 0 power equals x minus 1. Guys, what's anything to the 0 power? 1. 1 equals x minus 1. How do I solve that? So guess what my x-intercept is? 2, 0. 2, because that's what we just got when we set y equal to 0. 2, 0. And that's it. That's how you can do that with a calculator, and you would have, I promise, gotten the same thing. Did anybody happen to graph it? What did it say? Where did it cross the x-axis? 2, 0. Okay? Number 4, I just want to show you one more of these. Don't forget, if you use that method, are we ready to rewrite it as an exponent like I just did the one previous? No, because that x minus 2 is not in parentheses. I've got to do what with that minus 2 first? You've got to add that 2. So it's really log base 3 of x equals 2. Do you see the difference between when there's parentheses and when there's not parentheses? So when you're solving, please note that. Now here, 3 to the 2nd power will equal x. What is 3 squared? I guarantee you, if you graph this one, it's going to cross the x-axis where? At 9, 0. I guarantee it. You can go graph it and look. I guarantee it crosses the x-axis at 9, 0. Okay? Yes. All right. Any questions? I think both of these, if you haven't done them yet, I think they're both 7, 0. You can check them if you'd like. But I'm going to go ahead and give you guys your homework. If I'm wrong, tell me. But I think they're both 7. Your homework is this whole page. It's 92 problems. Joking. It's 9. There's one graph. There's one graph. Then there's 4 that you have to do those 4 answers that we just did. So y'all know how fast that is. And then there's 4 at the bottom that are a review, where you have to change logs to exponents and exponents to logs. So again, it should be really, really simple. What time we got here? What time we got here?
15.
Not 15. How much time we got? Oh, 4 minutes. That's probably because y'all talked too much today.
How did you get me?
I'm never mean. I'm a super nice guy.
Hi.
What's that? That's hurtful.
You're a sweetheart, Mr. Boswell.
I know.